I'm very pleased to introduce Arvind here. He comes from Intel, and he has a wealth of knowledge to share, and we're going to get right to it because he has a lot to cover. So please, a warm round of applause.
Good afternoon, everyone. I am Arvind Babu. I am from Intel India. I am one of the authors of this paper. About us, I am a technical lead at Intel, and I have been at Intel for 5 years with an overall experience of 7 years in the industry. I have recently taken on the role of a Scrum Master for my project that I am working on. Sajid is a senior manager at Intel. He has over 20 years of experience. His expertise is in software development, DevOps, and managerial expertise. Joshi is a software architect. He has more than 16 years of experience. He's worked with me closely for more than 5 years together. So that's a short introduction about us. This is the agenda that I intend to cover today. We'll first go over the traditional product lifecycle on how cloud solutions today are being deployed into production, from inception to the point where they are deployed, and what are the roles involved and what are the challenges we face because of that. We will then go about what is production testing, why we need it, and what are the things that are needed to set up your solution to be production test ready. We will also define how a production testing pipeline can be set up with common practices like continuous integration, delivery, and deployment. We will talk a little bit about quantifying telemetry data and how that can be leveraged to make your solution better. We will also call out some risks involved with production testing when it's not done right, and we will come to the conclusion and open up for Q&A. So, by the way, this is my first time presenting at a big conference like this. So, yeah. So, to briefly cover on how a cloud solution moves through various process levels in an organization before it's deployed, we can largely categorize them to fall under one of these 3 categories. The first one is the engineering role, where the team is responsible for maintaining a component. A component can be defined something as a part of a complex solution, where a team works just on a single component, delivers them. They employ their own processes to deliver such components. The second would be a system validation team. This team would be largely involved in bringing different components of the solution together, integrate them, do compatibility tests, and validate the end-to-end flow of the solution. Finally, the IT operations is the folks who maintain the cloud infrastructure. They manage the contingency of deployment failures. They take the solution to deployment, and the predominant roles that they are involved with, some of the tasks that they will be involved would be to take a backup of the databases, notify the customers of downtime, and other such related. So, some of the challenges with this approach is that when a deployment when we do deployment with downtime involved and it doesn't go well, we are forced to incur some extra time to fix the issues that arise out of it. These failures can be related specific to the production environment. You can have a lot of setup in your traditional test environments, but some factors within the production environment factors can influence deployment to go wrong. So, the other thing that I want to highlight here is that integration failures can also be affected by the asynchronous delivery of components. What this essentially means is that since every engineering team follows their own process, it's more likely that they are not going to deliver the solution at a time. If you are having an issue, you might, and you have a fix for that, you might probably have to wait for all the other components to deliver, and you have a time bound release until which you can deploy the fix into the production environment. The system validation and release timelines get affected because of this. So these are some of the challenges that you can find some common ground in most of the solutions out there who follow this methodology. So what is production testing? So to put it short, it's a simple validation phase where you run certain types of tests in the actual production environment, collect the results, and formulate an action plan. So why do we need this production testing? I mean, a lot of folks would be comfortable with having a strong process in place and take the solution for deployment. So do we really need such production testing validation phase? So the answer is yes and no. So there is no hard and fast rule to say that yeah, you have to do this and this is the only way to do it. There are multiple ways where you can achieve this. So what we are trying to aim here is for a consistent, stable and way to release your code into production in a stable manner at periodic intervals. So one of the reasons is cloud solutions cater to a wide range of audience across the globe. Issues arising from production, they require a quick response rate to address these issues. If you don't have a proper validation cycle or are impeded by numerous disruptions, it's more likely that your cloud solution is going to fail. So when you talk of traditional test environments, it's an approximation of your production environment. You don't replicate your production environment to test your solution. You cut corners, one because of cost and resources involved in setting up such environments. The quality inferred from the production environment will tend to carry more weight than the quality inferred from a traditional test environment. So some of the differences that you can call between such local test environments and production environment. One is the infrastructure differences. Infrastructure refers to the hardware, memory and network topology that we employ. The local test environment might not be suitable for scalable load tests because the resources allocated for such environments is low. And replicating a production environment within your local environment is just too expensive to do that. Another thing is the quality inference. So since the traditional test environment is an approximation of the production environment, quality inferred by running load tests or stress tests just infer quality or the performance of the solution in the said environment with the assumption that it would scale better with better resources. And if the same performance data or quality information is extracted from the production environment, you actually know how the solution is working. With respect to load simulation, you can write test tools in your local test environment and see how the solution performs, but it's not the real-time traffic that you get in the production environment. If you are able to write a code and deploy it in production and have a real-time traffic access that feature or code, you actually get how well that piece of code is working in production. So to set up your solution for production testing, we feel that these are some of the steps that you can take to get there. One is features. So feature and feature sets in general are to address some big functionality in your solution. Usually this is done as a big change. Feature can be very huge, and what this leads to is that a lot of code gets blocked in the developer's private branch or in an uncommitted code base, and this leads to high validation loads. So what we are suggesting is that features should be as small as possible. It should be something like a task which can be completed in a few hours. And the next thing is about feature flags. Feature flags is valuable to product design, where you can control the deployment of features into production. So there are multiple types of feature flags or toggles, if you like to call it. Some of them can be UI related, some of them can be deployment related. These can be fitted into configuration files of the solution, so that you can control a feature, whether it's getting deployed or not, it's being shown in the UI or not. So how this is going to be useful is that when you are deploying your product in production, deploying a solution in production, there will be delays and disruptions if there is some bug, and this disruption will be a huge impact in business. If you can just make sure that in production, if you can disable that code, that piece of code which is causing the problem, you can proceed with the deployment of the other things that do work. The next thing is about incorporating telemetry across the pipeline. So telemetry is the automated process of collecting data which is related to your solution. Data across the pipeline, when you collect data from across the pipeline, that I'll be speaking up in the next couple of slides, it allows you to address and prepare your solution, to better position your solution for failures and to counter the failures that arise. But with respect to collection of data, there is always concerns with privacy and legality of collection of such data. A lot of countries have laws and regulations against collecting data information, personally identifiable information. So we will be talking about anonymizing the data that is useful for the solution in later slides. So continuous integration, this is something which is engineering centric activity. So this is to address the large code change that come in, which increases the high validation loads. It is not directly related to the production environment, but it allows you to have code to be continuously checked in and get promoted into the master code base, mainline code base. So this is essential because you need this for a continuous delivery and a continuous deployment pipeline. The continuous delivery is follows the same principle. It relies on small code changes getting changed and validating those changes, and so that you can deliver a stable product for deployment. And continuous deployment is so continuous deployment and continuous delivery are two different things. Very often these things are mixed up. Continuous integration deals with delivering code where allowing developers to check in code multiple times of the day. This code will be unit tested, and that's the goal. And continuous delivery deals with automating the test to running automated tests to validate those code changes and stabilizing the feature or the component. And continuous deployment is a process of taking that solution and deploying it with various types of deployment methods into the actual production environment without manual intervention. So this is a production testing pipeline. This diagram you can find it in the proceedings, that's proceedings book. So this gray box that you see represents a component delivery pipeline. This portion of the diagram represents the solution level continuous delivery, and this is the deployment part of it. So I'll be explaining each one of these sections now. So continuous integration. So as mentioned earlier, this is one of steps required to set your solution for production. The continuous integration pipeline can be done with any number of tools which people are comfortable with, TeamCity, Jenkins. So the general philosophy here is that code should be committed always into one of the branches or into a source control. So the idea is that features come in here because the features have allow the developers to have a limited scope of changes. Since you have planned the task to be for a few hours, the code changes that get into your code base will be very minute, and this allows a fine control to identify what is failing, and it also decreases the validation time to write the automation test to validate those changes. So one of the things here that I would like to highlight is that when a developer checks in a code, there are a lot of processes to be followed. It can be code reviews, it can be unit tests, and this is where branching becomes useful. So a developer usually branches off the code to make his changes. He commits the change, he tries to merge it with a higher level of with a parent branch, and that branch is where the CI server will be running the unit test, validating those UTs, executing the UTs, and collecting the UT coverage results. And the promotion from a developer branch to a higher level CI server branch, for example, this would require a code review to be done. And these can be controlled with some tools like Gerrit, where you can force the code review to be done. And similarly, the promotion of the code for every check-in can be done. With continuous delivery, the CD runs right after the CI pulls or merges into a higher level code branch. Automation is a key to achieve this. I wouldn't say you need to do 100% automation, but having a higher level of automation coverage in this phase would allow you to validate almost all of your code changes. So as a developer, when I check in the code, the UT as part of the CI pipeline, the code gets validated with UTs, whatever can be covered in UTs, and it goes to the automation pipeline. So automation engineers can write the automation test for that and promote the check-in into run for compatibility tests and acceptance tests. And this would allow the small set of code changes to be delivered as part of the component. And this component delivery can be picked up by solution integrators in a similar CI fashion, continuous integration fashion, and that code can be committed, and a similar system end-to-end solution automation can be run, and a solution delivery can be delivered in place. So once a solution has been delivered as part of the CD pipeline, it is taken up into the production environment, and the deployment starts. So there are multiple ways in which how a deployment can be done. So I'm going to take up three types of deployment. One is the canary deployment. So canary deployment involves taking a solution and deploying it to a subset of your infrastructure. You reroute a part of the traffic to that subset of the infrastructure and run some tests over there. And this test allows you to control the features that needs to be enabled or disabled. So as part of the feature development, you will also be writing some config files with feature flags to control the deployment of this. So what essentially happens is that as users start using the features, you can measure how much the code is being validated in production and control the deployment of it. So once measure of that subset of the infrastructure results has been taken into account and you're confident of the feature's performance, you can then start rolling out to the rest of the infrastructure. So this involves taking individual pieces of code, having features disabled or enabled based on its performance in production, and you have the latest code running as part of the solution. So with respect to blue-green deployment, this is attempted where you have multiple copies of the solution in your production environment. So in this nodes, so usually you refer this to as pods, cloud pods and such, and you can mark them as blue or green. So it's really up to you on which pods you want to take up for deployment. So once you have marked that, you reroute all the traffic from one type of node to the other. So in this example, I'm rerouting all the traffic to the green pods that I've marked, and I'll be updating the latest version into the blue pods. So once over here you will have a window of opportunity to execute certain type of tests, like whether the connection strings are so a simple example would be like whether connection string is working, or whether the database is at a acceptable ping distance or a subnet distance. So once you have updated the latest version of the solution into the blue nodes, you will be rerouting the traffic from the green nodes into the blue, measuring how much. You can do it in a slow fashion. You can measure how the solution is performing in this in the latest version, and once the entire traffic has been rerouted into the blue nodes, you'll just update the green nodes and continue the process. And at the end, you'll have all the nodes, all the pods with the latest version of your solution. So with respect to A/B testing, it's not a deployment method, but it's a useful way to determine a visual experience for the user. Example that I can state for this is that if you're running an e-commerce site and you have two options, you're offering a discount and you have two options, and discount A is about having a discount with free delivery, and another one is about having a lesser discount with shipping charges. So you can route some of the users, and you can control the UI with some UI feature flags that you build, and when the solution goes live, you can tweak around to see how the users are responding to the discounts or to the offers. And based on whichever offer goes well, you can toggle the corresponding page in production where a global audience or the global audience is using it. So this can be made to work with a canary deployment or a blue-green deployment. So another thing that I want to touch upon here is about the release strategy and phase releases. I mentioned that features are to be scoped as minute as possible, that can be delivered and validated. So this means that you are going to have a lot of features, because there will be a lot of developers checking in a lot of features into the code base, and it requires a release strategy on how these features are going to. You will definitely be having some dependencies between these features. You will need to work out the dependency. You will need to work out on the feature flags that control the deployment. You can't have a feature disabled and have a dependent feature deployed. So so all this requires some release strategy planning and how this can be delivered. So as part of release strategy, one of the ways that we would like to suggest is doing a phase release. So phase release is something like you identify a type of user and allow him special access to features. So some of the phase releases that we think is like internal release, limited preview release, and a global rollout. So internal release can be something like resources within the company, validation engineers within the company use the actual production environment to validate some features. The features will be enabled only to those users. To the rest of the world, it will still look as it is with the older version of your solution. Limited preview is like a more larger audience. You can relate this more to beta. And the global rollout is the actual production and type of users who are using. So the advantages of doing the phase releases is that you have a feature A and feature B developed at some point of time, and feature A was developed first, feature B was developed first. It's not necessary that feature A needs to go into the production to the mass rollout. Feature B can very well be promoted for a global rollout because it might be performing well. If the feature A is required for more stability or more is like in a beta phase for a long time, it still can be in that beta phase. So this can be something correlated with how Facebook has been rolling out new search when they rolled out the new search engine, and only certain type of users got access to that search feature, where the rest of the world. So this is something related to that. So this is what I'm bringing up the deployment slide again. So I'm not sure you will be able to. You're clear over here, but this represents the production testers within your organization who are using your solution after deployment, and they have access to the production environment through your solution, and they are actually gauging how well the feature is working or not. So after they have given the approval, it can be rolled out for a global release over here. So that's pretty much about the pipeline, production testing pipeline. So to quantify telemetry data, so to quantify metric, what is a metric? It's a measure of a property that the solution possesses. What are the types of metrics that we will be interested in? It could be quality metrics with respect to performance measures, load times of the pages. It could be code metrics with respect to code coverage and bugs, and infrastructure metrics on how much resources, hardware resources the solution is consuming. So with respect to cloud solutions, some of the things that metrics that we can be interested is about the warnings and errors during deployment, the ping time between different components in the solution, and downtime, the uptime, the request served per minute. Those are some of the kind of metrics that you can be interested in. The reason why I had already mentioned about privacy and the legality behind collecting data. So that's the reason why we need to anonymize metrics. So you have different components within your solution. You can have identifiers for the components, generate some random integer or random name for the components. The component ID would be relevant to you as a developer when you're developing, but you will not be interested in the machine name, the IP, DNS, or this thing. But something like a subnet distance will help you with analyzing that performance of your solution and making improvements based on that. So the reason why anonymization is important is that you can be transparent with your customers on collecting the data and show like this is the data we are collecting from you. So some of the risks with production testing is that some of the risks with production testing is that when you size the feature wrong, you are increasing the risk of missing out validating some of the code changes. When you are working in a project, there's always deadlines, and when you take up a large feature size and you commit to that and you don't deliver, that's like you will be forced to cut corners with validation and force the deliverable to go through. And this is something that is going to risk your deployments in production. And with respect to deployment failures and rollbacks, you should not avoid the traditional validation methodologies. Production testing is meant only to enhance the quality of your solution, but not replace the existing ones. And never try to take the test databases and put it into your production environment. That's not what this is about. And net promoter scores. If you are impeded with a lot of deployment failures and you continuously roll back, it essentially means that you are not delivering any new feature to your customers, and there will be downtimes because of the deployment failures. and this type of things increases the detractors. Another point I would like to add is with respect to the feature flags. One of the risks involved is if you have a lot of features and you have a lot of feature flags, once these features go into the global rollout, the feature flag should be removed because it's already there in the production. If you don't, it will lead to a separate mini project where you will be involved with spending resources to just keep removing or managing these features. So recap, we went over the traditional life cycle on how cloud solutions are hosted and the roles involved and challenges. What is production testing, why we need it, what are the prerequisites that you can do for setting up your solution for production testing. We talked about the production testing pipeline with continuous integration, continuous delivery and deployment, different types of deployment, and where production testing is done, and quantifying and anonymizing telemetry data and the risks involved. So this is our contact information, and if you have any questions, I think we have time. We're good on time. Yeah. Okay. Yeah.
Especially along with deploying to production, it's usually done during that deploy time, and we're like holding off customers waiting for our tests to say, yeah, all is well. But say all is not well, and we roll back and call it nice.
Yeah. So if I can bring the slide over here.
There may also be production testing that you do just because you're not going to roll back. Are you talking more about the first of doing this during the deploy?
So the major goal over here is to not incur any downtime. So usually we say that, yeah, we are going to run a maintenance activity and you won't be able to access the services from this time to this time. So the idea here, so if you take this example of a blue-green deployment, you have the traffic with a load balancer accessing different pods in your environment. So now you are rerouting all the traffic into one of the, in this example you have 4 pods. We are rerouting all the traffic into 2 pods, and you are doing the upgrade of your solution in one of these 2 pods, in the blue pods. So you have a window of opportunity to see how your customers are still able to access the solution. And when you reroute some of the traffic to the new version, that's when you will be able to have a real-time traffic accessing your solution, and you are also have the opportunity to validate the users over there, usage of your features and everything over there. Yeah, at the end you will be at the bottom where everything is in the new version. If it doesn't work, you can always revert these 2 pods and go back to the old version. Yeah. Yeah.
So you talked about bringing features down to
some
level. They do that with some ginormous.
Yeah, it's a good question, and we too have the same issues with products. We have products that have been in the field for nearly 15 years, and we develop a whole lot of features that span over 3 months of development. And to break that down, the risks involved with that is that we develop for 3 months, and then at one point sometimes we find out that it's not feasible to do that. The idea is that you, with cloud-based solutions, with web-based solutions, the feature that you deliver can be sized down to something as minute as possible. It's not like you have to do it within 3 hours or 4 hours. It's really up to the complexity of the solution that you're trying to deliver. So it's up to you to determine how much I can scale it down so that I can split it, validate it. I do have a rudimentary diagram on the continuous integration framework and how it goes about. So the developer or feature branch that you see here, when a check-in happens, after code review, it goes into the CI server. And from here, after the CI server says, yeah, the unit tests are valid or anything, you can promote it to a higher level, say an automation branch. So what essentially it means here is that as part of the CI pass, if unit test has failed because of a code change, you can commit a code change over here that either fixes the test, or you can add more tests to promote your code level into the higher branch. And essentially from here, the same process, you trigger your automation run from here, from this branch. If there is no automation test written, this is a window of opportunity to write your automation. Traditionally, the code directly goes from here into the master, and we don't write the ATs, automation tests, and because of deadlines, we say, yeah, we'll do it later, but we never end up doing it. So essentially, if the code change is small, you get all these benefits inbuilt, that you get to write the UTs, you get to write the automation tests, and after which you get into the master from which the solution is built and delivered. Does that answer your question somewhat?
Yeah, it's just one of those challenging things sometimes.
Yeah, I agree. I agree.
That's something that just can't be.
So are you talking about like a feature that it's all being developed, it's all new, or are you talking about
Like
making a change to a feature?
new feature, something that's being added.
Yeah.
That you can't put just a small piece of it, or it doesn't make any sense. Small pieces.
So one of the advantages is that if you write a small piece of code, you can always have a feature flag that says don't run this in production. And you can always, in the production environment, you can have some type of test during deployment to see whether this is working or not. Get that result back and yeah, make a better solution, better feature.
Some of those feature flags that help to
Yeah.
Turn on
it
the
doesn't
other
make sense to the others, but you just don't turn it on for
Yeah.
clients or customers.
Hmm.
So get it out there.
Yeah. So essentially, when the entire code gets checked in, it will make its way into the production. When you take the CI, CD, and the deployment pipeline together, you check in. It necessarily does not mean that it will get deployed into production on the same day. It can be over the next 2 weeks, next month. But yeah, essentially, it will be in the production. It will end up in the production once it goes into the master branch. Any other question? Yeah.
Let's say you have an environment where you're typically not testing in production right now. You're doing it sort of the traditional way, where you test in QA and staging environments, and then you roll to production on deployment nights. I'm assuming that you would obviously need some amount of extra capacity if you're testing in production as well as running in production. Is there any kind of like a rule of thumb as to what that would look like, or do you know what I mean?
Kind of, yes, but the whole idea is that there are different deployment methods. I touched up upon 2 deployment methods, the canary and the blue-green. Canary is like to test small increments. You deploy to a small subset of your infrastructure and see how well it goes.
So this is just for testing functionality.
Yeah,
I'm trying to test
yeah, and
what the performance impact is.
yeah. I mean, when you really think about it, you have the phase releases. So there I had mentioned that you can have an internal release. You can have certain features just exposed to your internal testers, production testers. So they can be hooked on over there to see how well it's working. Though they don't control what is the production environment or this thing, they'll be acting as normal users, and you can hook up some kind of automation over there to see how well it goes. Whether as a user you will be able to use your solution or not. Yeah?
Is there a suggested duration of time you should let your release code bake in production before dumping the other code into the other blue containers or the other green containers?
So it's about the success of your deployment over there. If you feel that the feature is not working, you can always disable that feature and continue the deployment on the other, saying that disable this feature. You don't have to roll back continuously. I mean, rollbacks are costly operation with respect to IT and everything. it's usually frowned upon because a lot of effort goes in deployment and everything. So it's just better to disable that and move on and fix it at some other time.
Any more questions?
Okay. Thank you.